Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it's an honor and privilege to be serving you here today, as it is every day here in my virtual classroom. You step on the side, guys, we've been doing a lot of things involving quadratics before and factoring and such, and I'm going to continue that process right now, just going back into it. But they're not going to appear as quadratics, at least, well, you know what, the first few will, just to get your feet wet, make sure we still remember how to do some quadratic stuff. And then we're going to deal with things that look like they go to the 4th power, and 6th power, and 8th power, and things are just different powers, but you know what? They still have this innate quadratic form, this quadratic nature to them. And I want to jump into that and say, it's not too daunting. We either can make it look like a quadratic, or we can treat it like we would a quadratic for a very specific reason. And we might use some temporary variable substitution, but you know, the more we get into it, the faster I'll be able to go. I'm not going to linger on this one too long. There are 20 questions to do though, but you know, we take as much time as we need, and we recognize all the different kinds of factors we can when we see them. Starting with greatest common factors, of course, and then, you know what? We've been talking about difference of two squares and things like that, and I think that pops up here and there here. So let's just go ahead and dive right into it, guys. The first 4 questions that we're going to do are actually just quadratic. So go straight into them. Make sure we make sense of these. I got a 1x squared, which means I'm going to find what two numbers multiply to make negative 32 and add to make negative 4. Well, negative 8 times 4 is negative 32, and negative 8 plus 4 is negative 4. Therefore, it is negative 8 and positive 4. Again, I'm not going to live on things that we've done in the past for too long, just kind of reminding you of the idea with the quadratic, what we do there. Number 2, okay, I don't have a 6, I don't have a 1k squared here, but you know what, given that this is a 6, I can actually factor a 6 out of these 3 terms right here. And you factor a 6 out, and then we'll have a 1k squared, and then plus 15k, plus 54. And that looks like a 9 and 6 going right there. 9 times 6 is 54. 9 plus 6 is 15. So that will become k plus 9 times k plus 6. And of course, you leave the 6 on the outside. We're factoring completely. This expression needs to be equivalent to that expression there. Moving forward, guys, number 3. This time we do not have a common factor. So we're going to have to assume this. All these are factorable. So assuming this is factorable, we're going to do some sort of n times n. It's not going to be a 2n times 2n, though, because that'll give me only even plus evens, and that's an odd value. So this has to be some sort of 4n times n. So we're going to work factors of 30 here, which are always even and odd factors, either 30 times 1, 15 times 2, 10 times 3, or 5 times 6. And positive product, negative sum means minus minus here. So let's play with this a little bit. 30 would be too big there. You know what? Also, though, we're going to have this be the even number. So this will either have to be my 30, my 10, my 6, or my 2, because I got to get even plus odd here. So 30 is too big, 10 is too big, 6 is 24. Whoops, I want to put a 6 there. 6 is 24, 6 times 5, 24, 29. There it is. Just strategizing with you out loud, making sure you got an idea of that. Number 4. This is 5 is a prime number, so this will be some sort of 5m times m. And then plus minus here with a negative product. I don't know if this will be plus or minus or the other way around just yet. But one of those things, guys, with this being an even number, I got to choose even factors of 64 because 5 and 1 are odd numbers. So I got to get an even plus an even going. So there's an 8 times 8. Well, you know what? Most factors of 64 are evens. 8 times 8, 16 times 4, 32 times 2. I don't know my factors. And 64 times 1 I'm not going to do. Let's start with 12. Let's see. 12 is too big. Not 12. What was I saying? 16 and 4. 4 and 16 is 16m minus 20. No. 16 is too big on the other side. Let's try. I like to go with 8 and 8. Let's start with that. 8 and 8. Actually, 8's going to work. Negative 40 plus 8 is negative 32. So I need to switch these signs here. Sorry if what I'm saying sounds like I'm almost talking to myself more than anything else. This just kind of goes into the form of what I would mentally process. At this point, we've talked a lot of strategy. So that's me going through that. And honestly, guys, that's going to be a lot of what I'm going to go through. My goal for this thing is not to get you to factor these. This is getting your feet wet again, what I'm going to probably say out loud for factoring. If I don't say anything too fast out loud with this stuff, it's because I already figured it out. So if I just figured it out, then boom, I'll just crack it. What I'm going to do, though, is talk about these. So with these ones here, now I have x to the 4th and 8x squared minus 8x squared plus 15. Not quite a quadratic. Right? Not quite a quadratic, but they still have that quadratic form. Now, what do I mean by that? When we look at a quadratic equation like this one here, this is degree 2, This is degree 1. This is degree 0. That's what quadratic trinomials written in standard form will do. They'll have 2, 1, 0. Well, this has degree 4, 2, 0. This has degree 6, 3, 0. They almost take on that quadratic. It's almost as if the degrees have common factors. You see, instead of 2, 1, 0, it is 4, 2, 0, 6, 3, 0. Still ends in 0, still ends in a constant, and they descend in an equal degree all the way down, almost as if they're common factors within the degrees themselves. That means, potentially, we're still looking at something here that's being squared. Instead of x to the fourth, like x squared would be squared in that case. This 8x squared means that x squared is being raised to the first power, and then plus 15. What am I doing here? What I'm doing is I'm re-representing this as a quadratic. I'm giving it its quadratic form and saying something is being squared, something is being raised to the first power, and we have a something as a constant. It's not just a single x that's being squared anymore. In this case, it's actually an x squared that's actually being squared. So this thing takes on the exact same forms a quadratic would, only instead of an x, we have an x squared that's going in its place. Meaning we would factor this the same thing as we would factor, say, x squared minus 8x plus 15. Or better yet, I don't want to just put x squared minus 8x plus 15 right here to consider what it looks like when we factor it, because we already have this variable, right? This variable is already present. So, one thing that we do sometimes, and by saying we, I mean just math teachers teaching math students and things to help us out, is if this visual gives you a little bit of a headache in what you're looking at with the x squared and the parentheses and things like that, you can use another variable temporarily, to make sense of what it is that you're looking at. And what we tend to do through calculus and such, and I don't know, some books might use the letter A. I think I've seen the letter A. We tend to use what's called U substitution. I don't know where U came from with it. If U's already used, then you use V and things like that. But I've used U substitution before. So we say, hey, let's let U equal x squared. This is going to be a temporary variable. I'm temporarily going to place U in place of x squared. Now, why am I saying x squared? Temporarily substitute. 1 second. Temporarily substitute. Let's let U equal x squared. Why am I doing x squared? Because x squared is the thing that is apparently being squared. Right? X squared, x squared. So if U takes x squared's place, instead of x squared, I'm going to write a U. We'll get U squared. Instead of minus 8 times x squared, it's minus 8U, and then plus 15. Now, what am I doing here? What I'm doing is I'm making things look easier for me. Now, when I say me, I don't actually mean me as a person, but I mean the student, the person who's working on this. When you look at this, I don't know, or this, it's like, get that away. When you look at this, you're like, oh, okay, yeah, I've done these before. I did that right up here. Now that it's actually quadratic, it's not in your way as far as what it is we're going to do with it. If I asked you to factor this straight up, I hope you'd be able to. What two numbers multiply to 15 and add to negative 8? That's negative 5 and negative 3. So U minus 5 times U minus 3. And that's what I'm doing. I'm factoring this, and I'm letting the letter U help me out, see it as a quadratic, and write this out plain as day. But it was a temporary substitution. I temporarily substituted U for x squared, because ultimately I need to factor x to the fourth minus 8x squared plus 15. Now, U helped me out perceive it as a quadratic. Thank you. I'm now going to go back to the x squared that I had. Instead of U, I'm going back to x squared. This is x squared minus 5 times x squared minus 3. Now, this is not a requirement by any means. In fact, I personally don't do it myself. I do it in calculus when I'm doing integration. I use it in calculus. I don't use it for these things here. I'm perfectly okay with being able to perceive what's underneath here and write it out kind of fast enough so it's not in my way. And I can just focus on the numbers. The important numbers for me were 15 and negative 8. Right? Those were the important values for me. I don't care what these things say here, except for what I need to write inside there. So, the same kind of thing's happening here. X to the 6 minus x cubed minus 6. What you have to recognize is, as these go in descending equal order of degree here down to a constant, this has a quadratic-like nature. Something is being squared, the same thing is being raised to the first power here because of that natural descending order. This time it's x cubed. X cubed is being squared. X cubed is being raised to the first power. And I'm only putting in parentheses to give you that idea of that quantified thing. This is raised to the first power. This is being squared, things like that. So if you want to do the whole let u equal x squared thing here, again, let's go ahead and substitute u, not x squared, x cubed here. Let u equal x cubed. U is going to temporarily substitute for x cubed, so I'll get u squared minus u minus 6. One more time, just this, maybe not one more time. I'm going to do this several times, but eventually, guys, I will dump the u substitution. I'll just go straight into the, hey, it's x cubed, and we're going to do something with it. Or just, see if you can feel comfortable with it. Either way, we're going to be factoring this, what two numbers multiply to make negative 6 and add to make negative 1. That would be negative 3 and negative 2. U minus 3 times u, and positive 2. Right there. So x cubed was being substituted by u, and I'm going to go ahead and put an x cubed right back in there. X cubed plus 2. Again, my goal is to factor what the original thing was right here, and we're able to do that. Okay, the next one here. Once again, u substitution, and it looks like it's going to be, once again, for a x... Oh, well, no, I'm sorry. Look, this actually is the letter u, literally. So you know what? You want to put x in its place this time? Let's let x equal u squared. Remember, u squared would be u to the 4th, right? That'd be u squared minus 16 u squared plus 64. So x is going to take place of this. So this will almost look as natural as we've seen all our lives. X squared minus 16x plus 64. That's great, right? We're going to factor this. We have to put u back in the end. But that's as natural as they come for us. Now, I do happen to notice that this looks like a perfect square trinomial. Square x, square 8, and double x times 8. Of course, with a minus here, meaning it's going to be x minus 8 quantity squared. And again, I'm stating all this stuff almost as if the assumption that you've seen some of my videos before, or you've gone as far as what we're doing here. So that should look pretty okay to you guys. Now, we're not finished because u squared has to jump back into the picture. That's going to be u squared minus 8 quantity squared, as I substituted it back in. Now, is the whole worksheet like this? Sort of. There are some things that dive into it, and I did build the worksheet through kind of randomization of sorts, but I want to make sure I got a special case of a perfect square trinomial. And if you notice here, this is a difference of two squares. This one's important. This one's important because you recognizing this is a difference of two squares will carry forward through some future problems that we do. So right here, recognizing this is m to the 8th. Now, I don't have a middle term, if you will. If this is like difference of two squares, if this is like some sort of a squared minus b squared, let's recognize what's being squared in both of these things. Well, in this case, m to the 4th is being squared, and right here 10 is being squared. I mean, this is, I'm not going to do u substitution right here. We're straight up, we're already there. We do this on our own already in difference of two squares and recognizing that. Honestly, I probably could have said the same thing here if it weren't for the u squared right there. But m to the 4th is being squared. 10 is being squared. And here, this is a case of m to the 4th plus 10 times m to the 4th minus 10. That's the whole a plus b times a minus b. That's how these things do factor. Now, this is not the last time, I know this for a fact as far as when I did create this. This is not the last time we're going to see a difference of two squares, not just in the original problem though, it will show up in factors. Kind of spoiler alert, you're going to see difference of two squares show up in factors, but you're going to have to recognize it for when it shows up, and then go ahead and do it that way. All right, number 9. Let's see if we can do u substitution without me writing what goes there in between. Recognizing that u is going to be taking place of, and recognizing that we have that case, that it is a quadratic form, degree 8, 4, 0. It kind of goes down by 4s all the way to 0 there. Something's being squared, something's being raised to the first power, and then something there. What is that something? That is x to the 4th power. So without actually writing that one in parentheses, see if you kind of prefer this look. Straight up and say, all right, it's going in for x to the 4th. X to the 4th is squared. And x to the 4th to the first power, etc. 10 plus 8 is 18. 10 times 8 is 80. So u plus 10 times u plus 8. So x to the 4th, jump on back in. What do I want to do here? I did want this in purple, didn't I? There we go. I don't know what color purple there. All right, so back to green. That's going to be x to the 4th plus 10 times x to the 4th plus 8. Not one of my prouder moments of doing this video thing here. I do recognize that This one's kind of hard to teach through just doing problems sometimes. You really have to. I mean, the only reason I say it is because we know all these problems take on that form. So it comes as no surprise. It'd be nice if I mixed it with other kinds of problems, and then you got to see this for what it is. But so this can become a little commonplace. But again, like I said, the good news for you is you get to practice factoring, unless you're just watching me do it. I hope you're practicing some of the factoring on your own. I want to help you recognize what it is that we put into these things. So, okay, so we put U substitution there. Let's try one without U substitution straight up and say, what are we squaring here? We are squaring m to the fourth. And that same m to the fourth is being raised to the first power here, and then minus 8. And I write that so we know that when we factor this, we know that it's going to be m to the fourth and m to the fourth here. And this is what I do. I actually don't even write this part. I say it's an m to the fourth, and I kind of write this part out, get it out of the way for my own perception's sake, so I don't forget it as well. And then then I deal with the 7 and the negative 8. Honestly, this to me is a little more confusing to look at than not. The parentheses, it's just too much. I want to look at the 7 and the negative 8. And I am asking myself what two numbers multiply to make negative 8 and add to make 7, and that's a plus 7 and a minus 1. Now, this is the first problem of sorts where within the factorization, there is actually deeper factorization to be had. And you might wonder what I'm talking about here. M to the fourth minus 1. Now, if you look at this number 8, we had m to the 8th minus 100, and I asked you to factor, and we say, hey, we got a difference of 2 squares. Because 100 is 10 squared, and m to the 8th is m to the 4th squared. We actually have that here as well. You see, 1 is 1 squared, and m to the 4th is m squared squared. This right here, just as a side note, m to the 4th minus 1 is m squared squared minus 1 squared. This is a difference of 2 squares that we're looking at here. This turns into m squared plus 1 times m squared minus 1. That's actually what that becomes there. So this m to the 4th plus 7 is actually multiplying by that. There's the factorization. But m squared minus 1, I mean, this is as classic case of difference of 2 squares as there is. This is m squared minus 1 squared, right? This is as difference of 2 squares as you can get. No 4th power trickery right here. This is m plus 1 times m minus 1 straight up. That's one you really want to recognize. This one is, you got to practice that a little bit. But this m squared plus 1 still exists here, and m to the 4th plus 7. And that, ladies and gentlemen, that is the final factorization of this thing. We factor this down to the bone. Anything that can factor, we take care of. Now, Mr. Robinson, why was this the first time with an m to the 4th or something like that with a minus that you factored these? How come you didn't do that with x squared minus 3? Well, 3 is not a perfect square. When we factor things, we want to factor out integers only, not radicals, not fractions, things like that. And x squared minus 5, right? 5's not a perfect square. 8's not a perfect square. 10's not a perfect square. So in 3, this is a difference of 2 cubes. Well, that's not a perfect cube or perfect square. That's a cubic. So it doesn't work there. These are differences of 2 squares where we have perfect squares, so we recognize 1 is 1 squared. So as we keep breaking it down, it still stays as a 1. As long as there's a difference of 2 squares with a 1, I can keep breaking it down. Now, why didn't I do it with m squared plus 1? Because there is no sum of 2 squares with real integer factors and, things like that. M squared minus 1, I'm not going to get deep into it. We've talked about this in the past, that the linear term cancels. This is negative 1m plus 1m, and they're gone. M squared plus 1, there is no sum of 2 squares without there being some sort of linear term. There is no sum of 2 squares. That doesn't factor down anymore. A difference of 2 squares does. A squared minus b squared factors down to a plus b times a minus b, and that's what we're dealing with. Now, this shows up, I think, only a few times on this thing, but look for them. Look for them. All right, now the back page, we're going to probably find more common factors here, and we're going to start seeing, as you can see, when the a value is not 1. And I hope you're comfortable with that a little bit, because that's the stuff that I might go a little fast through, provided that I work through it at my own speed. We're just going to play with the U substitution stuff, difference of 2 squares factoring, and break it down more. And then, we'll be done with the video within probably the half-hour mark with the 10 questions in 10 minutes. I don't know, maybe not. All right. Number 11. Now, first things first, guys, this doesn't change common factor. You might be asking what common factor? The negative. Factor in, they were in standard form, a negative factors out to begin with. Do not forget that. And now that we have a set of parentheses, guys, u substitution is fine and dandy. If you want to say let u equal x to the fourth, as x to the fourth would be squared and stuff like that, that's great. If you recognize that x to the fourth is the thing being squared and you don't want to write the extra set of parentheses and stuff, let's see if you can work with me here and dive straight into it. Otherwise, continue with u. Just make sure you insert x to the fourth back in. I'm going to go on my own version of what I do now. So right here, as I continue to factor this, we need to figure out what two numbers multiply to make negative 30 and add to make 11. But I'm going to go ahead and stick the x to the fourths right now. I recognize that x to the fourth is what's going to happen here. X to the fourth times x to the fourth is x to the eighth. Combine an x to the fourth with an x to the fourth, you get an x to the fourth. I'm already taken care of there. I'm not going to continue forward on kind of that trek. What did I do? Hold on, I made a mistake. I factored out a negative, but I didn't factor out the negative. Hold on. Factor out the negative, and that'll give you a negative there, and that'll give you a plus there. I spoke over my work. I do apologize. Let me, brain food right here. All right, there we go. Because immediately I told myself no two numbers, as I was talking, no two numbers multiply to make negative 30 and add to make positive 11. What two numbers multiply to make positive 30 and add to make negative 11? That'll be minus 5 and minus 6. Now the negative stays factored outside, as we did that. There is no difference of two squares here because 5 and 6 aren't perfect squares. See, it is one of those things where, when do I recognize that I have a difference of two squares? Well, literally, when you have a difference of two squares. The x to the fourth might not call attention to me as much as the perfect square here, if it exists. I know my perfect square values 1, 4, 9, 16, 25, and they call to me when I see them. Right? They're just there. I see them for what they are, and the more that you do this kind of math, I guess the more it clicks for you that way. All right, number 12. Once again, seek a perfect square before you start factoring, please. I believe that I can factor a 3 out of here. If not, I'm in trouble with the 189. That number probably gets a little too large for me to love playing with. So this time, actually factor out the 3. 48 divided by 3 is 16, and 189 divided by 3 is 63. So plus 63 there. So this being an a to the 8th, that's a to the 4th squared and a to the 4th and things like that. So we know it's going to be an a to the 4th when it comes to factoring. What two numbers multiply to make positive 63 and add to make negative 16? Well, of course, negative 7 and negative 9. Like that. We would be done. But I noticed this 9. It calls to me, and it's a binomial, a subtraction, if you will. It is a difference of two squares. We're squaring a squared here. See, another reason I don't like the u substitution too much is, we got to plug something in there. And what? We're going to do u substitution again, let u equal a squared. I don't know. I think at some point and I'm not saying u substitution's bad at all. I'm saying if you feel like there's a way you can live without it, or you recognize what's there, I don't want to stop you. See, some of my students are almost led to believe that they're like, so what do we have to put in for u? What's the u? And I'm like, guys, u's just a letter. You can use a Greek symbol. You can draw a stick figure picture. The point is to create the appearance of a quadratic for ourselves. We want it to look like a quadratic because of our comfortable nature with it, if that's what you're most comfortable with. So when we look at something like this that's like, ooh, what's that? Or, ooh, what's that? We say, oh, this is calming to me. There is no requirement for this. That's not just like drawing a diamond, right? Drawing the diamond to factor these things. That's not a requirement at all. It's a visual aid to perhaps alleviate your perception of the problem. It doesn't enough for me that I feel like I need to put it in its place to make it happen on a personal level. I'm providing it for you. For me in calculus, it does. And for most people, it does. There's a specific reason for it. But for me in algebra, for this particular instance, no. I mean, I showed you on the front. You want to continue with it. That's fine. A to the 4th minus 7, again, not a difference of two squares. A to the 4th minus 9 is, because 9 is a perfect square of 3. A squared is being squared here, so this is a squared plus 3 times a squared minus 3. Now, 3 not being a perfect square means this is not a difference of two squares, just like that is not. We are fully factored. Sorry for over-explaining. Looks like we'll not be done in the half hour's time. All right, number 13. 3 does not look to be a common factor this time here, so it looks like we're going to have to deal with the card that we were dealt. So m cubed is being squared, and you can tell from the linear term here, as long as you recognize that this goes down in kind of an even fashion, in equal fashion, 6, 3, 0, kind of subtracting 3 each time, then it takes on quadratic form. So it's the m cubed that's being squared over here. So I know this is going to be a 3m cubed here, and this is going to be an m cubed here. So now we're minus minus, by the way, positive product and negative sum. We're going to not find out what two numbers multiply to make 25 and add to make negative 20. We got to kind of deal with what this times this plus this times this is to get negative 20. I mean, we've talked about that before. I'm not going to dwell on it. So you got 25 and 1 or 5 and 5. 25 would be too large of a number to jump into here to make negative 20 back. So it's got to be 5 and 5. Otherwise, it's not factorable. So that's negative 15 minus 5, which is negative 20. That seems to pan out. So this is the factorization. You know what? I'm done. I'm done. This is the hard. So like I said, this is the hard part, making a solution guide video out of this, because I want to deal my mental process to you for you to make sense of strategy. But I want you to try this on your own in a way as well. So it's almost like when I start this next problem here, if you're a student who's kind of watching this, writing this answer is just great. You wrote the answer. Did you understand what I did? I don't know. Just make sense of this first part here. This factorable, no common factor though. X to the fourth is being squared there. So I know that when I factor it, it's 5x to the fourth times x to the fourth. And I'm going to put a plus and minus here because I got a negative product. I don't know if this is where they start or where they finish, but I do know that that's kind of where they go. At this point, if you want to try and factor on your own, pause the video and then go back to me because I already got this one in my head. Now, 4 is either 2 times 2 or 4 times 1, but because this is a negative 1, it can't be 2 and 2 because that'll leave me with even, and even plus even. I need to get an odd plus odd, so either it's 4 and 1 or 1 and 4. If I put a 4 here, it's too big. 5 times 4 is 20, so it's not that. So it's going to be 4 and 1. So let's try and put the 4 and 1 here, test it out. That's negative 5 plus 4, and that's negative 1. If this got me a positive 1, I would just switch the plus and the minus. So there's that. Now, we're not done, because x to the fourth minus 1 is, like last time, a difference of two squares. So this is 5x to the fourth plus 4 times x squared plus 1 times x squared minus 1. We've seen that before. And x squared minus 1 is x plus 1 times x minus 1. So 5x to the fourth plus 4 times x squared plus 1 times x plus 1 times x minus 1. Never fails. I'd love to try and get some that are larger numbers. If this started off as, say, like a 16, like right here, then this would be a 4, and then this would be a 2. It keeps breaking down. I'd love to do something like that, but then that means we'd have to have a super larger factor to jump into here, and I don't know. Maybe that would be too hard to do. All right, number 15. 11 being a prime number is good. No common factor here, but let's go ahead and keep working that out. So this is going to be 11u cubed, right? U cubed is being squared there, times u cubed. Let's try the plus or minus out here with that 4. When you get 43 out, we can't, once again, not a 2 and 2 scenario because that'll leave me with even plus and even. So this is some sort of 4 and 1. Is it 4 and 1 or 1 and 4? If I do 1 there, that's negative 11 plus 4. That's too small. Negative 44 plus 1, though, that'd be negative 43. So that seems to work here. Check this out. Negative 44 plus 1 is negative 43. We want a positive 43. So the plus and minus are in the wrong spot there. That'd be minus and plus. Again, how much am I doing with you to help you out? I don't know. The more that I've talked, when I've talked strategy in the past, I hope some of it's making sense. This goes pretty blistering fast for me. And I'm checking for difference of two squares, things like that, if something surfaces. But if it's not there, I'll just move forward. All right, number 16. No common factor of a number, but a negative does exist to factor out. I'm going to factor the negative out here, and this time let's do this properly. That'll be 2x to the 6th plus 25x cubed plus 50. So the negative here, this is a 2x cubed times an x cubed, once again 2 being a prime number, which is kind of nice. All these pluses mean that's a plus and plus. 25 25 being an odd number means I need an even plus an odd, and I know this will have to be the even because 2 is already an even. So when I choose factors of 50, 50 I think always has an even and an odd factor. I'm going to make sure that the even factor goes here. So I can try 50, 25, 10, 2 against, 1, 2. Oh, hold on a second. Is there a... I'm sorry, 25 is not an even number. 50, 10, and 2 against 1, 5, and what are we doing? And 25. So, we're trying these ones here. 2 times 50, too big. 2 times 10, let's try it. 20 plus 5. Okay, that one works out. That one works out. And again, that's me displaying it for you so you know what kinds of numbers I'm trying. I'm trying as few as I need to. I don't need to go too big on that. What was this number? 10. So there we go right there. Plus, if I put an even number here, I'm probably overstating the whole even number thing here. If I put an even number here, 2 becomes a common factor with those values. So that won't work anyway. So anyway, so that factor's there. No difference of 2 squares or anything like that. That's the final factorization. Awesome. All right, 4 more problems here. Number 17 looks like u squared is happening here, right? Now this time with this being an 8, it's either 8 times 1 or 4 times 2. Well, with 5 being only odd factors, 5 and 1, I need to do an even plus an even to get 6. So it looks like it's going to be 4 and 2. 4u squared and 2u squared. There it is. 5 being a negative, that's plus minus. Let's see if they're in the right spot. Do I put 5 and 1 or 1 and 5? Negative 20 plus 2, no. Negative 4 plus 10, yes. So it's going to be that one right there. Whoopsie. 5 and 1. There it is. Now, almost a difference of 2 squares. If this 2 wasn't here, it would be a difference of 2 squares, the u squared minus 1. But it is there. Alas, we are finished. There's the factorization. All right, number 18 definitely looks like a common factor of something. A 2, a 6. 6 can factor out of those. So if I factor a 6 out, I get 10u to the 8th plus 3u to the 4th minus 4. All right, so the 6 stays on the outside there. And let's live on the inside here. Either 10 and 1 or 5 and 2. It doesn't look like I can play with the evens and odds too much on that part because 10, 1, 5, 2 are evens odds. Let's experiment with this a little bit. By the way, this to the 4th power, u to the 4th, because u to the 4th, I think you know at this point. So let's try those to start, the plus and minus. Sometimes we have to experiment a little bit. I do know the 4, it can't be 2 and 2 because I need to get evens here. And plus, and you know what? If I can't put 4 here because that would give me a common factor with 10. So 4 has to go there, 1 there if this works. Negative 40, nope, that doesn't work. So let's try 5 and 2 instead. Let's try 5 and 2. Now I got to place the 4 over here because I can't have the common factor with that. 4 and 1. Let's try that. Negative 5 plus 8. Yes, that works. Now this, once again, not a difference of 2 squares because the 2 that exists right there. And I am done. So I only tested as many as 2 things. The first one that I really did test, I saw was too big automatically. Nope. And then we're done. Only tested 1 thing. And we're good. All right. Number 19. Big numbers. Is 2 the largest number? 18, 45, 22. Yeah. You can factor out a 2 from here, but that's it. And we get 18 x to the 6th plus 45x cubed plus 22. Hey, 22 isn't too many, doesn't have too many factors there, just 2 and 11, an odd and an even. Keep that in mind as we do 45 there. And 18 has an odd and even factor each time as well. So when we work out 45, we want to get an odd plus an even. Plus, we don't want any common factors sitting within. I don't know which numbers do work out here, though, because it's just not, I just don't know yet. But x cubed and x cubed. Let's start with 18. We know these are pluses. That's good. We can't put 22 there. That'd be too big. If you put 1 there with 22, that would be 18 plus 22. That's 40. It's not it, though, so that doesn't work. Looks like 18 is not the number. Oh, sorry. I'm sorry. I didn't try 11 and 2. I didn't try 11 and 2. Let's try that. 2 and 11. That's 36 plus 11. Actually, that was close. That's 47, but that's also not it. Okay, so that doesn't work out. I'm visually doing these for you. Normally I wouldn't. I do that mentally normally, writing those out. I do put the 18 and the 1, but the other ones I would kind of do on my own. I want you to see what numbers I'm putting in there. So 9 and 2, I'll try next with, 22, too big. I think 22 here is going to be too large multiplying by this number. So we can try the 22 and 1 again. So that'll be 9 plus 44, also too big. So let's try 11. Again, the 11 here is too big as well. So let's try 11 and 2. Oh, can't be 2 right there, right? Can't have an even number. So that won't work either. So now let's try 6 and 3. Let's try 6 and 3. So same thing. I can't put now the even numbers here, the 22. So I'll try 11 and 2 like that. So that'll be 12 plus 33, and that is 45. That one works out. So again, and that's, normally I wouldn't write all that stuff and erase that. I would kind of just leave it and see what I got to do. But that's what it breaks down to. And there's my factorization. We're all good. And for those who like to cry their love of 18 times 22 and do your diamond with that, have fun with it. This is my go-to here. If it's not yours, I apologize. Good number sense is always good for your math. And finally, we can factor a 3 out of here, and we get 10x to the 6th minus 7x cubed plus 1. I always love a plus 1 because we know that has to be a 1 and a 1. So let me spit this out for you to start. Maybe I don't know whether this is 10 and 1 or 5 and 2 yet, but I know positive product, negative sum, this is going to be a minus 1 and a minus 1. That's glorious for me. So is this 10x cubed, by the way, x cubed, and 1x cubed? Let me just put a x cubed. Is it 10x cubed and x cubed, or is it 5x cubed and 2x cubed? Let's just try it. Negative 10 minus 1? No. Let's try 5x cubed and 2x cubed. Negative 5 minus 2. Yup. That negative 7 right there. And there it is. Now, once again, no difference of 2 squares, cubes, anything like that. I haven't done sum or difference of 2 cubes with you guys in video form yet. I think that's coming in, the next video. But that ought to do it for this video, guys. This is Mr. Robinson. Thank you so much for watching this one. I don't know how helpful it was because I'm dealing my own strategies when I get to the factoring portion. But like I said, you practice the factoring on your own. What I did with the U substitution, for me, kind of fell to the wayside at some point. I just said, what am I squaring? Recognizing it's quadratic. Like I said, in this academic exercise, it's not as fun, but you knowing that those are what they are automatically kind of makes it a little less strategic. Like when I'm saying over here, like I'm squaring x cubed, like I'm already knowing that it's quadratic form. So like maybe sometimes maybe it wouldn't be as obvious, and that's something we can get to play with in this kind of thing. But anyway, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. Take care.